Your agent booked the meeting, moved the file, and sent the message. Now go and look at the record. It does not say the agent did any of that. It says you did. That is not a logging bug. When an agent runs on a human's credential, the system on the other end never sees an agent. It sees you. The group that ranks security risks for agent applications put that problem at number 3 on its list, above supply chain and above code execution. Your agent does not have an identity. It has your keys. There are 3 questions hiding inside every action your agent takes, and almost everyone collapses them into one. Who is acting? On whose authority? And what may it touch? Identity is a name. Delegation is a chain. Authorization is a boundary. Picture the oldest version of this. You are away, and somebody has to sign for things. Hand over your signature stamp, and every page comes back looking like you signed it. Or write a letter of authority that names them, names you, and lists which accounts they may touch. Same work either way, completely different record. Season 2 taught least privilege as the first offense. This episode is what it needs underneath, a name to attach the limit to. So what actually breaks? That same body put it in one sentence. Without a distinct governed identity of its own, an agent operates in an attribution gap that makes enforcing true least privilege impossible. You cannot enforce a limit on something you cannot name. Their work example is familiar. An agent gets access on behalf of the person who built it. Other people then use that agent, and everyone is quietly acting as the builder. Same stamp, many hands, and the record shows one name every time. Their companion list for machine credentials names the mirror image. In their words, humans using non-human credentials causes loss of accountability and privilege misuse. And the fix was written down at the start of 2020 on the internet's own standards track. The distinction it draws is exactly the stamp and the letter. Impersonation hands one party all the rights of another, indistinguishable from them in that context. That is your own key in your agent's hand. Under delegation, the first party keeps an identity of its own and acts as itself representing you. In practice, that is one field. A token carries a claim for the subject and one for the actor. The subject is you. The actor is whatever holds the request, and the actor claim nests. The service acting right now sits on the outside, and whoever handed it the work sits nested within, so the token carries the order of who acted. Only the current actor counts for an access decision. The names underneath are history. Nobody had to invent this for agents. The actor chain is the half, almost nobody wired up. Now the recent part. A paper describes an attack that does not smuggle instructions at all. Almost every agent defense so far draws its boundary around instructions, checking whether text is giving an order. This one leaves the orders alone. It corrupts the data the agent believes came from its own tools, like a record identifier or an origin marker. The agent does exactly what you asked, to the wrong object. The letter is genuine. Somebody changed the account number on it. In the author's words, current agents do not isolate trusted data from untrusted data. They found working versions against shipping products, including the coding agent behind this channel, and reported everyone to the vendors before submission. In each demonstration, a person still clicked approve on a prompt that could not say what it was approving. So how did the defenses do? Against ordinary instruction injection, nothing in that battery let more than a fraction of a percent through. Against the new attack, the best attacker result was 50%, against an undefended baseline of just over 49. Some barely moved it, others cut it by half, only one stopped it. Season 3 closed on a design called Camel, which separates untrusted content from instructions by construction. At looser settings, it still leaked, 23 to 25%, and one of those settings had an implementation bug the authors reported upstream. Run strict, it stopped the attack completely at 0%. So the answer we ended on held, at a setting tighter than the one measured then. And now what strict costs? The agents finished about 36.5% of their ordinary work against 86.5% undefended. Tight enough to work, and tight enough that almost nothing gets signed. So why not train the model to be careful about who it is listening to? A paper this year looked inside the models. They perceive the source of text from how it sounds, not from the label attached to it. Injected text lands in the same internal space as the trusted role it imitates, and that confusion predicts whether an attack works before the model generates a single word. Sounding like a role is indistinguishable from being one. A second paper this June puts it plainly. Action safety cannot be installed in weights. A system that cannot tell who is speaking is not the system that should decide what the speaker may do. So enforcement moves outside the model, and one identity vendor shipped that. Entra gives an agent its own account in the directory, and Microsoft says the platform is generally available. It is separate from a person and from the application identities behind ordinary services, which assume a long life and a known owner. An agent might last minutes. The documentation names what those identities let an agent do, as itself, on behalf of a person using that person's rights, or as the thing checking who is calling it. And every agent identity has to name a human sponsor. Then the same documentation says something remarkable. Inherited permissions are not visible as permissions in the admin center. They are only observable in the token contents at runtime, so the half an agent inherited cannot be looked up at all. That is not a gotcha. It is a disclosed consequence of inheritance, and the best evidence that the third question is still hard. So why is there not simply a standard? The standards picture is not a race between two proposals. It is a stampede. A single search of the Internet Engineering Task Force's own tracker returns more than 100 active drafts with agent in the title. Almost all are individual submissions at their earliest revisions, and not one has been adopted by a working group. Early discussion groups have opened, which is the designed on-ramp. Nothing has come out of them yet. And 5 unrelated drafts gave themselves the same acronym. The Identity Foundation working on this hands protocol work off to its working groups rather than doing it there. They are very good at naming the gaps. Gaps in standards around delegated authority, in their words. So what do you change this week? Least privilege is not a principle you hold. It is a field somebody typed. Move 1. Find the access mode on anything the agent writes to. On one platform, a memory store attaches writable by default, and read-only is enforced at the file system level. Episode 3 covered what happens when untrusted content reaches that store. Move 2. Learn which controls the model checks and which the machine enforces. Permission rules are evaluated before a command runs, based on the command string, and in the default mode on a separate classifier's judgment too. The operating system enforces the boundary on the process, so it holds whatever the model chose to run. The same page says the plain part out loud. Sandboxing reduces risk. It is not a complete isolation boundary. Move 3. Read your defaults. That same page admits its default read scope still allows reading credential files, with no built-in credential deny list. Move 4. Record which human sponsored the agent. Now the honest limits. Every defense in that comparison was measured on a fixed benchmark, and this field has learned what those flatter. A study late last year took 12 recent defenses, most of which had reported near zero attack success, and got past most of them above 90% once the attacker moved second. Then the half that gets left out. A team this June ran an adaptive protocol against a defense that sits outside the model, and it held. Attack success fell roughly sixfold, from about 26% down to about 4%. Their own caveat is that this is one small data point on a weak model, so the state of it is unresolved, not lost. And one question is still open. Should the agent act as you or as itself? The shorter the agent's life, the more it should act as itself. The more irreversible the action, the more a named human belongs on the token. So carry this shape. Who is acting, on whose authority, and what may it touch? Your agent answers the first one with your name, which is why the other two collapse into it. The test fits on one line. Can you name what your agent may touch? And can you name who signed for it? If the answer to either is just your own name, you do not have delegation. You have a stamp in somebody else's hand. Scope all of it to the middle of 2026, because it is moving fast. This is episode 6 of Put AI to Work, our season on getting real work out of AI agents, one working skill per episode. The full free AI course is on the channel. Subscribe, and the next time your agent does something on your behalf, you will know whose name is on it.